reduction reactions it is undergoing. So therefore, the reduction of CO gives ethyl alcohol, that is the third property. The fourth property is the CO and O is together is removed as minus of CO2. This is called a decarboxylation. The decarboxylation. Here only one reaction. Here 4 reactions are there. In the decarboxylation, once again we have around 5 different decarboxylations you can notice. The lastly, you have certain properties on this alkyl group. Because of the presence of the COOH, certain reactions are taking place, that is called alpha halogenation. There is only one reaction of this category, so this will take as a one reaction. Totally here acidic property is one reaction. So 1 plus 4, 5 plus 1, 6 plus 5, 11 plus 1, 12. These 12 reactions, if you properly remember, I hope all the properties of the acetic acid you can remember properly. Then let us discuss what is this acidity. Acidity property, let us take up here. A CH3COOH readily liberates the hydrogen. It becomes into what? CH3CO minus. This has got a beautiful resonance stabilization. So therefore, the removal of the H plus will become very much easy. The reason is here explained as a resonance stability is the reason. So the O minus, that is CH3, this side CO, that side O minus will come. If this minus comes here, again this polarizes, these two structures will be goes on exchanging mutually, that's called resonance, and because of that the proton removal will be very easy. That's why we have evidences like if I add sodium hydroxide, immediately sodium acetate will be formed plus water, salt formation, salt and water, acid and base, salt and water. Sodium bicarbonate, HCO3, even a weak base when you add also, it is reacting and forming into the sodium salt of the acetic acid is formed. In addition to that, carbon dioxide is released, this is from the bicarbonate CO3, you are getting a carbon dioxide, this reaction is called effervescence. Effervescence. So this is a identification test also. If a given compound is carboxylic acid, add bicarbonate, you will get all bubbles of carbon dioxide will be coming, as if that the milk is boiling, the solution gives out the bubbles and giving some bubbles to break up small noise called hissing noise also you can find out. So these two are the evidences for the acidity. It also react with sodium metal, liberate the hydrogen gas, all three refers its acidity. Okay. Now let us take this acid derivative formation. Acid derivative formation, second reaction. So the acetic acid will react with the 4 different reagents and gives the 4 different derivatives. In all the derivatives, what is happening? The OH will be replaced and a new group will be entering. The first derivative either with the PCl3 or with the PCl5 or with the SOCl2, this is known as thionyl chloride. Phosphorus pentachloride or trichloride or thionyl chloride, the OH will be removed and you will get a CH3COCl. This is known as acid chloride. Acid chloride is a derivative of acid. 4 derivatives you are getting. Acid chloride is for. Consequently, the byproduct, if you take thionyl chloride, SO and O will become SO2, one Cl will come here, H and Cl byproducts will be formed. That's a balancing the reaction, that's not important in fact. Acetic acid, when you treat it with P2O5, P2O5 is a anhydride form of the phosphoric acid, very reactive reagent. It will absorb the moisture wherever it is. If you take 2 acetic acids, see here, 2 acetic acids, from the 2 moles of acetic acid, HOH is removed, 1 O comes in the center. So therefore, from the 2 moles of acetic acid, a water molecule is by force it is taken away. That taken water will take this P2O5 will become into phosphoric acid, and this is becoming into a acetic anhydride. This is known as acetic anhydride. Anhydride means what? No water. So, the anhydrate, there is a statement, anhydrates are anhydrates as long as there is no water. If you add water, what happens, you see, immediately you will get back the two acetic acids. If you add this water absorbing medium, then immediately anhydrate is formed. Okay, right. Similarly, when you add ammonia, ester we will add first. So, ethyl alcohol you add. Acetic acid plus ethyl alcohol in presence of a few drops of concentrated sulfuric acid. It is only a catalyst, therefore, really speaking, very few drops of sulfuric acid, heat it strongly. This is a must. If you heat it strongly, the ethanol will enter in the place of OH. So, acetic acid will be as it is CH3CO. Instead of OH, a ethoxy group will be coming. So, this is known as esters, ethyl ester. Most of the esters in the universally, they are exhibiting a beautiful flowers. So, flowers, the beautiful smell of the flowers and fruits are because of the smaller esters like ethyl acetate is also a one of this test. So, therefore, either for acetic acid or for the ethyl alcohol, the test can be used. In the flask, if it is acetic acid is given, you add ethanol and heat it to sulfuric acid. After that, nullify this sulfuric acid by adding some bicarbonate, you will get a beautiful the fruity smell.